Assalamu alaikum. My name is Muhammad Usama, and in this video I am going to show you the implementation of the Demorgans law and the other Boolean functions which are given in the manual with the help of the Verilog codes. This thing is this code over here is the Demorgans law. The first expression of the Demorgans law. I have already implemented this. So when I right click over here, locate in the RTL viewer, I can see this diagram. This diagram is same which is given in the Proteus simulation. I have shown in the Proteus simulation and the truth table. So I would like to open that. This thing I am going to open that. So okay, let's just wait a second. That thing is over here. So you can see that the function is given in this way, and my diagram is in this way. The diagrams are the same. So now I would have to check whether the output waveforms are verifying the truth table or not. So for this I would have to click over here, University Program WF, and insert node or bus, find node, list, select all, click on OK, change the time periods, take this to be 50, this to be 100, this to be 200, 200, and this to be 400. So when I run this code, you can see that that my waveform will be satisfying the truth table. So the waveform which I will be getting is shown in this manner. You can see that these three are these are the basically inputs and these are the basically outputs. So when I open the truth table for this expression, I can see that when both inputs are 0, the output is 1, and all the output is 0 in all other options. So you can see that when the inputs are 0, the output is 1, and the output is 0 in all other combinations. So this was the first case for the Demorgans law, and for the second one, you can see the second expression for the Demorgans law. This is the second expression for the Demorgans law. When I locate the RTL viewer, you can see the circuit diagram over here. So from the Proteus simulation, you can see that the circuit diagram over here and this thing over here is same. So this is the verification. So now if I try to open the waveform viewer to check either my waveform is right or wrong, so click on file, click on new, and click on Verilog HDL file, University Program VWF, and click on insert nodes or bus, node finder, list, select all, and click on OK, and then click on OK, and change the time periods, this to be 50, select this to be 100, select this to be 200, this is to be 200, and this one is going to be 400. 400. When I run the simulation, you can see that the simulation will be satisfying the truth table. So for the truth table, I want to show you the simulation over here. These are basically the inputs and these are the outputs. So the truth table says that the output will be 0 when both inputs are 1, and the output will be 1 in all other cases. When both inputs are 1, the output will be 0. So you can see that when the both inputs are 1, the output will be 0, and the output is 1 in all other cases. So you can verify this case from over here. So now I am going to implement the other functions which are the given Boolean functions. The next function over here is f is equal to x plus y dot z. So to implement this function f is equal to x plus y dot z, I have made a Verilog code over here. So this is the Verilog code of the f is equal to x plus y dot z. When I locate in the RTL viewer, I can see that this is the basically circuit diagram. So circuit diagram over here can be drawn in this way, and the diagram which is shown over here is the same. So when I go to the truth table and go to the waveform viewer and verify the waveforms, I can clearly check that. Let me just go to the waveform viewer. This is the waveform viewer, file, new, university, program viewer. Okay, select nodes or bus, node finder, list, select all, okay and okay, and change the time periods. Let this time period to be 50. This one is going to be 100, 100. This one is going to be 200, 200, and this one is going to be 400, 400. So when I run this code, I can see that the waveform will be satisfying my truth table. So for this, let me show you the truth table for this function. The truth table for this function has been drawn in this simulation. Let me show you. The truth table for this function is given over here. So it means this is giving the 0 output when all the inputs are 0. So you can see that when x is 0, y 0 and z is 0, the output is 0. The x is 0, y is 0 and the z is 0, then the final output is going to be 0. So in this way you can verify the truth table of this function, and the other two Boolean functions are given in the next document, which I have to show you. When I locate this, and in the RTL viewer I can see that the function is shown over here, and the simulation circuit which is given is in the shown over here. Let me show you. And this is the simulation circuit for this program, and you can see that clearly. This is A complement B plus C complement D. So for this you can see that the function A complement B plus C complement dot D. So when I open this in the waveform viewer, you can see that file, new, university, program, VWF, click on OK, and insert node or bus, node finder, list, click on here, OK, OK. Change the time periods. Let me change the time period of this to be 50. This is 50. This is 100. This is 200. Oh my sorry. This one is 200. This one is going to be 400, and this is the output basically, so it's going to be 800. Let's just change it. So when I run this circuit, I can see that the truth table will be verifying by the help of this simulation. So when I get the outputs, I will verify the output waveform with the help of the truth table. This is the output waveform. In the circuit you can see that you can verify that circuit when A, B, C, D are 0. When A, B, C, D are 0, then the output is 0. When A is 0, B is 0, C is 0 and D is 0, then the output is 0. You can clearly see that over here, and this whole truth table is verified in this way. So the last circuit which I'm going to implement is over here. So when I go to the RTL viewer, I can see that the circuit over I'm so sorry, the circuit is made in the RTL viewer, which is over here. So you can see that A complement B plus C complement D. This is the function. This is the output of the that particular function. So this was today's video. I hope you have enjoyed that. If you have enjoyed the video, give it a thumbs up, and Allah Hafiz.